Good afternoon. My name is Brandon Carter. I'm an application engineer with Ally PLM Solutions. I want to welcome you to Ally PLM NX Lunch Bytes series. For those of you not familiar with Lunch Bytes, it's a series to briefly explore capabilities within NX that are often overlooked. I recognize most of your names, so I think everybody is returning for Lunch Bytes. We want our Lunch Bytes to be valuable to you, so please let us hear your suggestions on topics we should cover. And if you could send those to me via email, that would be good. Also, if you have any questions regarding today's session, please just make a note of them and send them in an email as well. There's a few of you on the line, so we'll have you in listen-only mode. Probably a few more is going to join as we go. So we'll just go ahead and get started. Today's topic is on designing in the context of the assembly, also known as top-down design. So our agenda for this session is, what's the difference between make work part and make displayed part? Just to kind of clarify that, if anybody has any questions there, kind of, like I said, show the difference. What does the entire assembly filter do for us? How to create new components in the context of the assembly, basically a new component and also a new parent in the other direction. We're going to look at wave linking using WAVE wave to create those interpart links. We're going to look at the whole series command. We're going to look at the assembly cutout command. And then at the end, I want to I'll call it a tip and trick, but just to kind of make you aware of maybe another area to use that create new component, and where that would be is on imported bodies. So with that, let's get started. Just a little bit about top-down design in general. I know this is a wordy slide, but just generally what we're looking at is referencing or modeling in the context of the assembly. So while we're in the context of the assembly, we can reference background components to assure fit. The reference, like I said, you can edit into parts using the make work part command. So there's kind of three areas I listed here. You can edit and do individual features by referencing those and doing it in the context of assembly. We can do complete parts from top to bottom, meaning top to bottom to finish the model. And we can create the new component using the create new component command. We can also create an entire assembly, which would be a sub-assembly in this case, using the top-down approach. We just use the create new component command and then use an assembly template to kind of create that container for the new subassembly. So really what we're looking at is working or modeling in the context of the assembly as the topic of the lunch bite. The difference between make work part and make displayed part is the fact that make work part changes to the active component file or the work part, and any features that we create from that point on will be associated to that new work part, meaning the history tree, the part navigator, is of the work part. Same thing with make displayed part, however the difference is make work part will just show in the context of the assembly, whereas make display part will open up its own window and it behaves just as if we did a file open on the component. That entire assembly filter I mentioned, you see there in our selection toolbar where the selection scope is, you see within work part only, within work part and components, and entire assembly. If you've never designed in the context of the assembly, you've probably only used within work part because it's within the part that we're working on, that whatever's active. So obviously that's only going to allow me to select the current work part geometry with that filter. If I'd use within work part and components, it'll allow me to select obviously the geometry in the current work part, but also the child components is selectable. Meaning if I was in a subassembly, I could also grab geometry from those child components. And entire assembly, which we'll look at here in just a little bit, allows all geometry across the entire assembly file to be selectable, even more than just the child components as the middle option. If I select create new component, we're going to start a brand new component in my work part. So right now my work part, if you look at the screenshot on the bottom left, is plate assembly. If I create a new component, a new model component, you see I'm selecting the template, I'm going to call it new part. It's going to add a new underscore part to plate assembly. So that's starting a brand new part. That'll be saved as its own .prt file, basically a separate component. Then we would make new underscore part the work part and start building our model features. The other direction is create new parent. So you see that we had plate assembly was active. We went create new parent, select an assembly template. I call it new top level assembly. So now the new top level assembly is this file, and plate assembly is a subassembly inside of that top level. So there we're actually going the other direction, the parent rather than the child. So let's go ahead and take a look at those ideas here inside NX. So here I have a fixture. Bear with me, a little bit of delay. I'm rotating this around. It's keeping up pretty good right now, but if it starts getting choppy, I apologize. It's because it's over the web service that you're watching. We have this exhaust fixture set up, and you see the exhaust pipes in there. Basically what we want to do is just take a look initially here at make work part versus make display part. If I come in here and I'll just grab one of these pipes, if I right click, you see make work part is there in bold. So anytime you see a bold on a right click shortcut menu, that means that that's my double click action. I have make display part as well. If I select make work part, see how it edits in to this pipe, which is called exhaust 400, in the context of the assembly, which is exhaust assembly fixture at the top. So it shows me that I am designing or editing in the context of the assembly. If I make changes, first of all, if I go over to the part navigator, this part navigator, this history tree, is of the work part, which means exhaust 400. Now this, I've actually imported some of this geometry. That's why I see the body. Sometimes you hear that referred to as a dumb solid, and I'll illustrate why I did that a little bit later to show you another tip and trick. But if this was a native NX file, whether it's a body, whether you see sketch, extrude, whatever, the point is the history tree here in Part Navigator is of the work part. If I go back to my Assembly Navigator tab and I just double click on the top level assembly or make that the work part, then I went back to, in this case, the top level assembly. If I right click on it, I can do a make displayed part instead, and you'll see how it opens it up in its own window. You see it's only listed as exhaust 400. Obviously this is my history tree for exhaust 400, and what it's done is it's opened it up as a separate window. You see that I have my assembly in a background window, and then exhaust 400 is the active window. I could switch between those. I can also come over here to my assembly navigator, right click, say display parent. It'll list the parent files, whether it's subassembly or top level assembly, and that'll switch it back. It'll keep it as a work part, but I can double click on the top level to make that the work part, basically going back to that assembly level. Here you see that the exhaust assembly fixture, like I said, is the work part, so this part navigator is associated with that. I do not have any assembly features, so I have nothing in that history tree or part navigator at this point. So there's the difference between make work part and make display part. The next thing we want to do is we want to build a component. I'm just going to build a little block in here. We're going to call it a spacer block between the left upright and the main support underneath. So on my assemblies toolbar, I'm going to come up and say I want to create a new component. I want to create a new model. I'm just going to give it a name. Remember, as this creates it, it's going to build this as a separate .prt file. Here, once I've defined a name, it says, well, you can select geometry to be pulled down in there, and I'll show you an example of that at the end of the presentation. But if I want to create something from scratch, just don't pick anything and hit OK. So what you're going to see is down at the bottom, now I have a holder for spacer block. If I double click that, that'll make it the work part. So now I've edited in to spacer block in the context of the assembly, and notice how the background components are kind of see-through or translucent. I don't have anything modeled yet for spacer block, so I don't have a history tree yet. Okay, so let's go ahead and start modeling something. I'm just going to come in here and create a sketch. Notice how my search scope has set to within work part only by default. So if I come down here, see how I can't reference any background geometry, nothing's highlighting, only that base coordinate system for my my sketch, and my work part. If I change this to an entire assembly, you'll see that I can start referencing background components. So I'm just going to reference the side of that main support there to create my sketch. And we're going to talk about building associativity here in the next little section. But if I just come up here, I'm in a sketch, maybe I use project curve. So I'm going to come in here and borrow edges to ensure fit. Okay, and a couple things, that's kind of the name of the game, not only designing in the context assembly and being in that environment, but referencing background components to assure that fit. Now, a little mentionable item, I'll talk about this a little more with a slide later, but you see that in NX 8, they added this little button called Create Interpart Link. So whenever I have entire assembly selected and I would grab these edges like this, which exist outside the work part in the entire assembly, if I turn that on, that would actually build some interpart links on the fly for me. And we'll talk about that a little more in a minute. Right now, I do not have those selected. I grab those edges. So what it's saying is, well, because you didn't have that on, you made an unassociative interpart selection, meaning outside the work part. Do you want to go ahead and create these as non-associative curves and put some, simple constraints on there? So right now this is not going to be associative, and we're going to compare some examples of where we will make it associative just in a little bit. Let me go ahead and finish my profile. I'm just going to grab the top of that spacer block and just create a profile. I'm going to go ahead and make a couple corners, trim that off into a rectangle. But I referenced the background components so that I knew what size. I didn't have to draw that from sketch or from scratch or go out and measure that. So let me go ahead and make this a little taller. I'm just going to take advantage of the continuous auto dimensioning to go ahead and fully define this. So there's my profile. I've created a sketch. You see, for my work part, which is spacer block, I've created a sketch in that part. But in the context of the assembly, referenced it for shape. This toolbar that's popping up, this is an NX 8.5. If you check out what's new in NX 8.5 Part 1, I talk about this toolbar. It's just another toolbar at my cursor location. I'm going to go ahead and grab extrude off of that. Let me reset my dialog. I'm going to grab that sketch. So I have that sketch that we projected earlier. I'm just going to extrude that out, and I'm just going to snap to an object. And because I have entire assembly on, I can go ahead and grab an endpoint to reference for the length. Now, anytime you snap to a point like that, especially with extrude there, that is not associative in NX. We will talk about wave linking here in a little bit where we will make that associative. But I've started building my tree and the work part. If I want to go back to the top level assembly, I'm just going to double click on the top level assembly to make that my work part. Now I'm back at the top level. Just to show that that's not associative, if I make this side vertical piece my work part and I come in here and do some kind of synchronous move, because that is an imported body, and I hit OK, I did a move face, so you see I'm building features inside the work part. That's longer, and you see that did not, the little block in here did not get longer as well. So it's not associative is the point. Okay, so the goal there was to kind of show you, even get you thinking about what's associative, what's not associative, and also to see how to use a make work part versus make display part, and how to create a new part in the context of the assembly. Okay, so maybe we want to take that a step farther and make it associative. So you'll see that there's an item called Wave, W-A-V-E, and this is the Wave Geometry Linker. It is on the assembly toolbar. It looks like two little links together. On the right, you see the different types of geometry that we can use. So I can grab edges for curves, points, datums, just faces, bodies, region of faces, mirror body. So the different types of things to kind of filter how we grab geometry. As I mentioned, with NX 8, they added this button here called Create Interpart Link. So if I have my selection scope and entire assembly, and I toggle that on whenever I select an edge that exists outside the work part, it'll say, hey, do you want to add this to the work part as a wave link? So what it's trying to do is, because of how you selected it, with that option on, it's trying to do, if I go back a slide, this step on the fly for you rather than specifically going to the command. Like I said, this button was added in NX 8. So either way, in 8, prior to 8, you have to go into the Wave Geometry Linker tool. Okay, let's go ahead and take a look at wave linking. Over here on the right, I have this vertical piece, and you see it has these features on this plate that are holding the ends of the, basically there's a little plunger in there, and it's holding the ends of the exhaust in place. So I'm just going to hide that component, and let's just build part of that from scratch using top-down modeling or designing in the context assembly. So I've got rid of that part, whether I deleted it, whatever it may be. I'm just going to come in here and say create a new component as we did before, and I'm just going to call this right upright. I'm not going to select any geometry because I want it to be a blank part. I'm going to model it from scratch. So now I've added another part to my assembly. It has no geometry in it. It's a placeholder. Remember, it'll be its own .prt file, and I'm going to make that my work part. So everything's done now. I'm going to go ahead and go out to a sketch. I'm going to change this to an entire assembly so I can reference that top face. And let's just go ahead and create the rough shape of that, the rectangular shape. I'll take advantage of my continuous auto dimensions. Change the thickness of that. Locate it here on the face. Maybe we'll move that away a little bit. And we need to move this up the hill so it fits, because those are kind of coming up at an angle. So there's my base sketch. We'll go ahead and extrude that sketch. Here, I'm going to show you how to specifically reference, but you'll see that I can even something as basic as getting an idea, just eyeballing, is one help even in doing in the context of the assembly. So it helps if I type in the right value. So I'm going to do 425 there for the height. So that's my first feature. I have a sketch and extrude in the right upright because that's my work part. Now I need to create those little solid pieces that come off, and they're actually going to go around this little bushing here, as you saw with the finished model that I turned off a minute ago. To make them associative, I want to come down to my assembly toolbar and grab the wave geometry linker. So we talked about in the slide the different types of geometry. I could grab the entire body. I'm going to grab face just to help me with my selection later. So when I grab face, I'm just going to start copying these what we call linked faces into the work part. So I'm just grabbing the top and the bottom. Go ahead and grab one more. I could grab them all to finish that part. I'm going to stop here with 3 just to make sure I get through the rest of my presentation. So if you look here at the work part, we have the base feature, extrude, and then each of these faces is linked. So this linked face is the key to building that interpart link or that associativity so that one part drives another part. So let's go ahead and come in here and build some construction geometry on top of that. I'm actually going to go ahead and move my sketch to the center. So I'm just in the sketch environment. I'm going to come off and pull some rough geometry off of there using profile. I'm going to actually come in here and build a little center line for construction. I'm going to go ahead and toggle that guy to construction so that won't be picked up from the extrude command. Add some constraints there. I made a parallel constraint. How wide do I want this to be? I want that to be 50 millimeters from the left off center, so I have enough meat over there. Now here I drew an open profile. So I didn't even dimension these last two guys. Just to show you, and what's new with the 8.5, we also talked about being able to do open profiles now. And if you're older than 8.5, using 8.0 or older, you would have to connect those lines over to the edge. But I'm going to take advantage of that open profile. There's one. Just to step through that again, let me go ahead and do one more there. I'm going to create the sketch again. Put that on center. I'm going to draw the profile off. I'm going to infer some constraints. There's parallel, so that'll give me the same orientation. I'm going to build another center line here. Go from the midpoint here over to the center. I'll make that construction again. And we'll build a couple constraints, make that parallel to get the right orientation there, and then we'll make that 65 as well and 50 from the center as we did before. So there's my other open profile. So notice they're at different orientations slightly, and they're also at different locations. I'm just referencing that copied face. Now the reason why I did the top and the top will define the sketch and the top of that feature, and the bottom I'm going to extrude to. So I'm just going to come up to extrude. Go ahead and grab my profile. Now it's an open profile, so it's wanting to do a sheet body. But if I turn on that option in 8.5 that we covered earlier a couple months ago in the Lunch Bytes, I can come in here and say I want to Boolean that and I want to Boolean it to that solid. So notice how it extends over and Boolean unites up to that first feature, that vertical extrude. While I'm in here, because I have the edge of that copied, why not go ahead and select that edge so it keeps a void as it extrudes. So there I have the basic profile. Also, I want it to be associative to that bottom face. So I'm going to turn on until extended, grab that linked face. So now I went down to that face. I'm going to repeat the same thing for the second sketch. Grab that guy. While we're at the sketch step, I'm going to go ahead and grab this edge. And we're going to turn on the option for the open profile. And until extended, I'm going to grab that bottom face, that linked face. So that's the key. The linked faces is what's building that interpart associativity. So if I go back to my top level assembly, you see that not only did we model those in the context so we know exactly where they need to fit, but if I come in here now and change that bushing and make that a little longer, remember we extruded until that face, so you'll see that this thickness here actually got thicker too. If I go back to top level, this thickness, it went to that face. Updated associative. Also, if something location-wise moves inside of my assembly, whether it's by an assembly constraint or a move like I'm doing here, if I just move these parts, move those to the right a little bit, notice how the hole jumps over. Notice how I still kept that 50 millimeters of meat because I dimensioned from the edge to the center of that sketch, which was at the center of that linked face. So the bottom line there is if I want to build interpart associativity, I'm going to use the wave geometry linker. Let's go ahead and take another look at another example of using wave linking. Let me go ahead and hide these pins over here. These are just little fixture pins. Hide these guys over here. So I have the back of the exhaust here, this component, and it's up to this plate. Right now there's holes in this exhaust plate, but they're not in this, what we call this inboard plate. So I want to make that my work part. I have the location of the holes already because of the exhaust. I'm just going to use my wave geometry linker. I'm going to do a composite curve, and it's going to allow me to grab those edges. I can do them all at once. I'm going to do multiple selections. So now in my part navigator, you see I have a couple of linked curves. And like I said, I could have done those with one selection. I just did apply accidentally in between. Either way, I could do them separate as different link curves or together. So while I'm still in this work part, if I go ahead and go to my hole command, and I just want to put a tapped hole or threaded hole in there, notice I can just reference those wave linked edges and drop those holes right on center. So I've created my holes in that work part. If I go back to the top level assembly, you see that it's kind of hard to see because of the background, the depth, but I have a hole now associated with that. So if something happened that I changed this exhaust plate, and this is an imported body, so I'm going to use synchronous modeling and face finder to make some changes. So if I come in here and move this hole and I want to set up my vector direction for how it's going to move, so I'm going to move that out, maybe 4 millimeters, make that change. That hole is also updated as well. So just to make sure you see that hole highlighted, if I come in there, you see the threaded hole, and it may maintain that alignment because I wave-linked the curves and associated the holes to those curves or edges. Okay, so a couple of different examples of wave linking. But the key there, interport associativity, gotta do wave. Okay, a couple more commands we want to look at. We want to look at the hole series command. A hole series, this is an option inside the hole command. You can create multiple holes using a hole series through multiple bodies in one work part. So there could be body 1, body 2, body 3, or more. Or you can do multiple bodies in an assembly, which we're going to look at here. Creating a hole series at the assembly level will actually drive linked features down into each body or component that we use. So you see the dialog, it has a start, a middle, and an end. The start, you can define a body for start, you can define a body or multiple bodies for middle, and you can define a body for end, and it'll create a whole series through those. We'll take a look at that in a second. The assembly cut, this is going to be a cutout or a feature that only exists at the assembly level. So in this case, this part navigator screenshot you see is a screenshot from my assembly. I've created an extruded feature, which is going to be my tool body, and then my assembly cut is basically a Boolean subtract operation where I can pick multiple bodies or multiple parts or components and then subtract that tool body out. The difference here, or one of the things to be aware of, that only exists at the assembly. So if I were to open up that second body or those individual component files, you would not see the resulting cutout. It only lives at the assembly level. All right, so let's take a look at the whole series. So I'm going to go to the whole command and grab whole series. I don't have any existing geometry, so I'm just going to go ahead and throw a couple points out here quickly. I got one point there. Let's go ahead and add some constraints and dimensioning there. I'll just put a little construction line, make that guy horizontal. Go ahead and drive some dimensions here to locate it. I need to move it to the right because I extended that a little bit earlier. All right, so there's my points for my whole command. So you'll see that there's a start, which has a body. So it's picking that first body the whole passes through. If I go to middle, see how it's picking up that middle body as it passes through. If I go to end, it's picking up that final body that it passes through. Okay, so I just have screw clearance. Notice in start, I have hole options for the start body. Middle, it says, hey, do you want to match the dimensions of the start hole? That way it's the same size. You can uncheck that and do some different fits, whether it's loose or even a custom fit. And then the end, that's where I'm going to define my depth, because this is looking at one hole, but it's doing a series through multiple bodies. And you see here I have a value of 20 millimeters. So let me just go ahead and accept the defaults. This feature resides, in this case, the way I applied it, at the assembly. So you see a screw hole series at the assembly, which is my current work part. If I go ahead and save this guy, and this first part, if I make a display part, so it opens up by itself, you see it has the holes through it. If I look at the part navigator, it does link those holes down into the individual component files, even though I created them at the assembly. If I go back to the assembly, just to do another one, if I make the work part, I'm not going to make display this time, but you see that it has the sides of the holes linked into that component. If I want to make a change, I can go back. I'm back at my assembly level. I can go back to my whole series, edit in there, and for example, instead of maybe at the end, I want it to be a certain depth, maybe I want it to go through the entire body. So now you see those holes update and they go through the entire body. Let's go ahead and do another whole series. I'm going to do it on the bottom up into the vertical uprights. I'm going to go ahead and place a couple holes again. Let's go ahead and build a little bit of construction geometry around that. Drive this, and we'll make this a little closer to the edge. All right, so those points are where my holes are going to be. So you see that now it's going from this body up into this body. So if I take a look, I have a start, which is the bottom plate. I have an end, which is the vertical plate, but you see the middle does not exist because this is only going in to two components. Okay, so what that means, if I have two components, I'm going to have a start and an end. If I have three components like the last example, I'll have one start, one middle, one end. If it's actually four components, I would have one start, two middles, and one end, because like I said, I can have the middle be the same as the start as far as the form and dimensions, as I said here. Okay, in this example, maybe for the start I want to change this to a counter bore. So you see how that updates down there. And for the end, instead of it just being a clearance hole, I want to do a tapped hole, maybe full thread, certain value depth. So now I have a second hole series. If we save that and I take a look at this as the displayed part, this vertical piece, now you see the two holes in there, and notice how it's a linked threaded hole because in the end body I changed that to threaded. So whole series is pretty slick. The final thing for this section, it's 1 o'clock right now. I'm going to run probably 5 minutes over. I apologize for that. Is doing the assembly cut. So right now I'm back to the top level assembly being my work part. I have those 2 hole series. Let's go ahead and do an extruded tool body. And I'll just create a simple shape here on that face. And we'll put that. That looks good. Make that a little wider. Not that this really matters for what we're trying to show, just to go ahead and constrain this guy. That looks good. All right, so there's our sketch. So I'm going to go ahead and flip this. Right, it's the Boolean should be set to none because I'm creating my own tool body here in the assembly. All right, so here we have extrude 3, which is the tool body, which I actually extended through the entire assembly. So if I want to do an assembly cut, I can come up, insert, combine, do an assembly cut where my other Boolean operations are. I can say what bodies do I want to be the target, basically what's going to be cut. I grab all 4 of those parts from left to right. Then I'm going to select my tool body, which is the extrude. Like I said, it lives in the assembly. And there is an option in here that'll hide the tool. So even though I have extrude shown right now, when I hit OK and it completes the cutout, it's actually hiding that tool body. So be aware of that. Like I said, this particular cutout only exists at the assembly. So if I come in here and find that right upright all the way over on the right, make that the displayed part, you do not see any pieces of the cutout down in the individual component. It only exists at the assembly level. All right, just to kind of wrap up this example, we looked at create new component. I can also create new parent. So right now, my top level at this point in time is exhaust assembly feature. I'm going to create a new assembly parent. So I'm just going to call this top level fixture. Find type. And what this is going to do, it's going to create a new file, which is now the new top level, and basically it made that last work part a subassembly in there. So I have the top level, and that is a subassembly. I just created that on the fly, which is handy. Maybe to finish off this design, I want to add a component. Maybe I have a table that this goes on, so I'm just going to come in here and grab this table. We'll add that in by constraints, assembly constraints. Maybe I want to touch that face to that face. Maybe I want to align this center reference plane to this center reference plane. I grab the right one. I'm just going to throw that in there and do that again. So I got the first constraint. Let's go ahead and align this plane to this plane, and then while we're in here, let's go ahead and do a center relationship. I could have done that as well. I'm going to grab this face. I'm going to do a 2 to 2, this face and this face, centered to this face and that face. So we just threw that in there and constrained it. So we had our top level. We have our exhaust, which is now exhaust assembly fixture, which is now a sub, and then we have this table, which is a sub-assembly. So if I right-click, I can make that the work part, so I could do work to that sub-assembly, or I can make it the display part, and then it would open up as a separate window, as we discussed earlier. All right, one last thing to wrap up with. I kind of said like a tip and trick or a different way of using create new component. I'm sure you've all imported something, whether it's from a customer or something from GrabCAD or whatever it may be, and on the left you open it up, and in Part Navigator it looks like it's an assembly, but it brings it into one .prt file, one NX model. So you have body 1 through body 9 on the left, and like I said, it looks like it's a subassembly or weldment or whatever you want to say. On the right, that's what I want to get to. I want to create that exhaust, keep that exhaust structure, but I want those bodies to be individual components. So I can use create new component to do so. Let me go ahead and close out of what I had earlier here. Bear with me one second. And I'm just going to open up a file that I imported called exhaust. This is where I took the screenshots from. So you see I have body 1 through body 9, and you see that each one of those bodies looks like it's a different component, which it is. So when I imported it, it brought multi-bodies into one PRT file, one NX file. So maybe my job is to work with this body 5, which is this plate back here where it mounts, and maybe I'm going to do CAM or manufacturing on that. So one thing I could do is I could do a file save as, delete everything out except for the part I want to keep, right? And then I'd have that part by itself. You could do that. All right. What if I wanted to build this as an assembly? Well, I could keep doing a file save as, delete what I didn't want, and keep the one body, but then I'd have to build my assembly back. So what I'm going to show you here is using create new component. So I'm going to create a new component. Let's just call the first one pipe 1, where we're going to save it. And before, when I was creating parts from scratch, I wasn't selecting anything. Now I'm going to select these bodies and basically pull them down into the part file. Okay, so there's body 1. I have create new component on my floating toolbar, so I'm going to call this pipe 2. Grab another body, hit OK. New component, call this pipe 3. Third body, hit OK. Grab another one, call it pipe 4, whatever the names I need these to be. These could be part numbers. Grab the fourth one, and I'm not going to do the end, but maybe just to grab one more. Let's go ahead and grab that. I'm just going to call it mount or plate or whatever you want to call it, and grab this end piece here, the one that I said we really needed to work on. So you see that it's pulled those bodies out. So I just have the ones on the end that I didn't mess with. If I look at my assembly structure, you see I have pipe 1, pipe 2, pipe 3, pipe 4, and mount. So those are now separate files. I have hide and show properties because it's here in the assembly. I still have my assembly structure. And if that mount was the piece that I was concerned about, I can right click, make that the display part. I could do a file open on the mount, do my CAM setup, machine the part, do my drawing, whatever I need to do for that customer, and I have my separate file, but I can maintain my assembly structure intact and basically create it just by selecting geometry. So I just wanted to share that technique with you. I think that's handy, especially when dealing with, those multi-body or even dumb solid files that come in when we import them. All right. Once again, I'm sorry I ran a little over. If you guys are used to me, I usually run over the 30 minutes. I like to talk too much. Just to wrap up here, as you probably know, these are where our Lunch Byte replays are, also where you can register for upcoming Lunch Bytes or see upcoming Lunch Byte topics are on our website, www.allyplm.com. You can go underneath resources and select Lunch Bytes. So you can register, see what they are, you can catch the replays, and as I mentioned earlier, you can suggest a topic. You can email those to me, or you see here's a spot on the website saying suggest a topic for our next Lunch Bytes. There's my contact information if you had any questions. Just so everybody's aware, upcoming training offerings here at Ally PLM. We have the CAD for the Essentials for NX Designers. It's 5 days for new users. The next 3 dates there. CAM class starting up in June with one of my coworkers, Chad. That'll be June 17th through 21st. Keep in mind, all of our classes can be taught online. If you need more information, go to the website or let us know. I appreciate your attention this afternoon. Once again, sorry I ran over a little bit. Hope you found this session informative. Just let us know if you have any questions, and have a great afternoon.